Today we're going to be starting with centers of triangles. There are four types that we're going to have to know today. They are circumcenter, incenter, centroid, and orthocenter. I'm going to break each of these down and we'll be done for the day. The circumcenter. I want you to take a look and see what you can notice about this triangle. You should notice that you have side length markers, meaning the sides are congruent here. That is to say, AX line segment is congruent to XB or BX, doesn't matter, line segment. Okay? You should notice those. I'm going to color coordinate this a little bit for you today. You should also see a different two-line marker here, which is to say BY is congruent to CY or YC. And you have a third set on the bottom. AZ is congruent to ZC. I also want you to notice that these lines are perpendicular to the sides of the triangle. So what makes a circumcenter is perpendicular bisectors, meaning cut in half. Important facts about the circumcenter, about the circumcenter is that it is equidistant. Let me write circumcenter real quick. It is equidistant from each vertex of the triangle. What this is saying, from AM is congruent to BM, which is congruent to CM. Just because I've not stated it, the point M on each of these triangles is the center type. So in this case, the circumcenter, for the next one will be incenter. Oops, sorry, messed up on that. AM, BM, and CM are all congruent. Okay, moving on to incenter. You should notice on incenter that you're going to have angles that are congruent. That is to say, angle XAM is congruent to ZAM. X to A to M, that angle is congruent to Z to A to M. Okay? Likewise for XBM, MBY, and YCM, MCZ. These are created by angle bisectors. So the incenter is equidistant from each side of the triangle. What this says those three are congruent. XM is congruent to YM, which is congruent to ZM. I'm going to skip centroid for now. I'm going to go to orthocenter. An orthocenter is created by an altitude. I'm going to show you what this means here in a second. An altitude is a perpendicular line to the side of a triangle. So if I take a perpendicular line to a side and I move it along my triangle, the place where it touches the opposite vertex is going to be how I get my altitude. In other words, my altitude is going to be this portion of my line segment. That'd be one of my altitudes, okay?
May I have your attention, please? Wanted to let you guys know that Coach Oswald's class is currently in the lead with 103 cans of food. Way to go, Coach Oswald's class. Thank you.
Sorry for the interruption. Food drive's going on at the school. Okay. I'm going to do important facts for my orthocenter. And this is just what I just now showed you, but an altitude, that's a terrible A. My altitude is created by a vertex connected to the opposite side so that it is perpendicular to that side. The intersection of altitudes is the orthocenter. Okay, done for that one. I want to point out how orthocenter is different from circumcenter and incenter. It is different because, first off, it does not have an angle bisector, and these side lengths do not have to be congruent. The non-mathematical way, and I'll erase this once I draw it, is that if you take a line on either of these two, it is going to curve like that, like that. I can't show you great on that one, sorry, but it is curving, whereas on orthocenter, they are completely straight. Okay? Okay. Moving on to my final one, which is my centroid, and also one that has the most stuff you need to have knowledge on. Centroid is created by medians, meaning I'm taking each of my sides and finding the middle of it and connecting it to the opposite vertex. So a median is created by a vertex connected to the opposite or midpoint of the opposite side. So I have my triangle. My midpoint is just the middle of each side. I'm going to connect to the opposite side. And the place of intersection is going to be my centroid. Okay? Okay. There are three things that you have to know for this. If I take line segment AM, it is going to be equal to, not congruent, equal, because this is going to be an equation, to 2/3 of my entire distance A to Y. So AM here is 2/3 of my entire distance. Okay? I'm going to show you, I can't really show you that one, but I'm going to show you the next two in just a second. The second one, MY, which is the little piece here, is 1/3 of AY. Which makes sense because if AM is going to be 2/3, the last remaining portion has to be 1/3 of it. The last one you have to know, AM is equal to 2 MYs. Okay, those are three you need to know. I'm going to show you. If I take my line segment MY here, I'm going to copy it. Maybe I shouldn't paste there. Paste. Move it over. I should have chosen a different color than black so I could see it here. Okay. So now I have three of that one line segment. I just copy and pasted. If I take these two and move it onto my AM, it fills it up. So 2 MYs is an AM. And if I have all three of them, I do get my AY, my total distance. That is the best that I can show you to help you to understand this. That's all we have today, just those 4 types of senders. The creative is what you need to look for to know which one to use. Important facts is what you need to look at to solve the problems.